Welcome, guys, to our session. We are very excited to present to you our talk on SRE with GitOps. So straight before diving in, probably a question to all of you. Are you all aware, or how many of you are aware of what SRE is about? Wow, that's amazing. And how many of you are already practicing SRE at your own organizations? Okay. And now, probably the last question. How many of you think SRE has anything at all to do with GitOps? Wow, okay. So I already have some great guys who will support me. But yes, so this is our aim today, to see how we talk about site reliability engineering, and we can tie this with GitOps. Why do we need GitOps for SRE? And for the technical aspects, we will look at how GitOps helps us to automate Kubernetes deployments using GitLab CI and Flux CD. So that's the technical part. But let's just start with a small introduction on our side, who we are and where we come from. So here we go. I am Manisha. I'm the product owner of SRE at Swisscom.
And I'm Marco Gonçalves. I'm a DevOps engineer at Swisscom at the same team as Manisha.
And since we both come from Swisscom, so probably just a few words. I hope you've heard about it. And if not, then we are doing something terribly wrong. Yes, very proud to say we are a large organization, 19,000 members in our family. We are more or less the best in what we do. Very proud about that as well. So as you see, we have been awarded as one of the most strongest telco brands, not only in Switzerland, but also across whole Europe. Now, what do we do? So we handle a lot of essential services, and question is, what are these services? So this is everything that you use when you start up your phone, right? Come to telephony, come to internet, Wi-Fi, television, but more importantly, also the emergency services. Now, what do I mean by that? So when someone calls up an ambulance, this ambulance has to know like which place this person is located so it can reach to that person with the shortest possible time. So that's like emergency call localization. So this is just one example of a critical service that we handle. But now let's just shift to a non-critical scenario. Let's just come to DevOps Days Zurich. So you want to give your friend a sneak peek into what's going on today, how the day 2 is progressing. So you want to set up something as a short post on LinkedIn, you open the phone and you see, oops, no network. Would you be pissed or not pissed at Swisscom? Frustrating, right? So that's exactly what we try to avoid at Swisscom. So we try to be as much possible reliable to our customers, and therefore reliability is quality. Reliability is everything for us. And therefore, we talk about site reliability engineering. But there is a small twist here. So we took the term from Google when they said, here you have SRE. Wow, this is a new concept. And we said, okay, now let's just see how we can adapt SRE to our own needs at Swisscom. Do we need it or not? And if we do, then how exactly? So therefore, we talk about service reliability. Makes sense, because we are offering services to our customers. So let's talk about services and not site or only resources. And therefore, today we would like to focus on how we can enable service reliability through 3 major aspects. First, we talk about efficiency. Question would be, what has efficiency got anything to do with reliability? Nothing. Everything, probably. Because being efficient is not only about how better we do our job, but it's also about how better we are able to provide our customers. In the end, efficiency might be about automating the manual operational processes which we have today in our organization. But by doing that, we eliminate that possible scenario which we put a person into where he or she might be prone to make manual mistakes. Second, making our services resilient enough. I think this one, more or less everyone would agree with me. Resiliency comes from the fact that our services are able to auto-heal themselves from disasters or failures. And third, I cannot be reliable if I don't know how to scale. So I have an expanding portfolio of my services for my customers, but surprise, surprise, I don't know how to scale. I am adding every layer of complexity with the additional services that I'm trying to add to my portfolio. So that's exactly the three segments which we are going to focus on in terms of service reliability. Now, when we talk about service reliability, at the end, it comes down to really the deployment or the lifecycle management of hundreds of resources or applications that we have running at Swisscom. And therefore, what we would like to see is how to harness reliability through all these three aspects: efficiency, scalability, and resiliency, through a GitOps-powered pull approach for CI/CD. So let's talk about GitOps. I think you've already heard about it. You are probably using it quite a lot. So it's nothing fancy. It's more or less a deployment approach which helps us in the lifecycle management of our applications. Interesting part, it helps to maintain Git or your version control system as the only source of truth. And this is what affects our reliability at the end of the day. So before we talk about GitOps and pull approach, let's just talk about CI/CD, which all of you guys are aware of, I would say. So a basic traditional CI/CD approach is where you have a version control system like Git for your source code. Then you have a CI part where you go through the stages of building your image, testing it, and then releasing it on a container registry like Artifactory, probably. And then you have the CD part. That's the deployment part. And here is where we have the differentiation between a push-pull mechanism. So let's talk about a traditional approach where you involve the DevOps guy and they are responsible for checking if there are new versions of your application now available on the container registry. And then decide if now I would apply that to my target environment or not. Does that make us sure that we have exactly the same state that we have declared on Git and it matches what we have on our target environment? No. And that's where we say, why involve a human when it is not needed? Probably yes, for review, but that's something we can come to later on, and it makes sense when you are on production. But probably if you're testing or if you're on lab, do we really need a human here? And rather, instead of having a human, can we not have a Kubernetes operator? And this is exactly what we are going to talk about. We are going to talk about Flux, who is then responsible for checking available application versions and then applying it to your target environment. We are going to talk in details about this, also going to see a demo. But before we do that, it's important that we have a look at how our CI pipeline is set up. Good for us to refer it when we see the demo.
Yes.
So,
thank you, Manisha. So the CI part will remain unchanged, whether it is a traditional push approach or a GitOps pull approach. So let's have just a quick overview in our traditional GitLab or CI pipeline. So we have a commit. This will trigger our pipeline. First step, build, test, and release. So for this, we are using Canico Project Executor. Why? Because we want to avoid running with privileged access or Docker in Docker. We will run a Docker file. This Docker file will build a simple Flask application, and also will run the unit test that we have in our project. So if the unit test fails, nothing new, we will stop the entire process. If the unit tests are a success, we will upload into Artifactory a temporary image. Next step. So we will scan our image for vulnerabilities. How are we doing this? So we are using the Git template container scanning. As default, you know the container scanning will not fail. And here we should and we could implement testings about the results of the container scanning. For the demo's purpose of today, we didn't do it, but we should do it definitely. So let's imagine that our image has a lot of issues. And so what we will do next? We will clean the image. The temporary image is still a temporary image from our Artifactory. How we will do this? with Cochrane. Why Cochrane? Because it's really simple, works as Docker commands, and we don't need to build image. Quite simple here, nothing new. So now imagine that actually everything was okay. Okay, so next step, tagging. So what we will do, we will we will fetch all the tags that we have in our GitLab repository. We will pick the latest, and we will increment the patch version. And why this is a common best practice, and then we will tag our commit, we will push it to GitLab, and then we will retag the temporary image that we have in Artifactory with the same tag. And now we are in sync. Git repository and Artifactory are now synchronized.
Cool. So now we talked about the CI part. Let's have a look at the deployment or the CD part, how we use it with Flux. So by the book definition, it would help us to automate our Kubernetes deployment every time we change one single line of code. That's the theory, but let's try to see how it works in practice. So the first step that we would like to do is bootstrap our cluster with Flux. Now, the bootstrapping process is nothing more than installing Flux on our cluster. But with that comes 3 outputs. So we will have certain controllers that will get installed. We will have custom resources. And then finally, what we will set up through this is a link in between our Git repository where you have the application source code, exactly as I will be showing you in the demo. And then what you have on your Kubernetes cluster, which is your target deployment environment. So just as an example, what you have here on the right is an example of how you can bootstrap your cluster with Flux. So of course, there are some specifications which you have to take into account, giving it a path to your GitLab instance, the project, if you're using a particular branch and so on. I think this part is quite intuitive enough. What's interesting is that we also have to give authentication, or we have to assign an authentication method for Flux to read or write on the repository that we are connecting it to. So here I'm using tokenauth. You could use the default deploy token which comes on GitLab, but that comes with the default read permissions. In this case, I want to enable Flux not only to check for the changes and apply to the Kubernetes cluster, but also to be, able to write to the application manifests. Why? We will see later. Then finally, you also have some components which are like the image automation controller. And this is the guy who will help us to replace that manual DevOps operation when scanning for images and how to apply that on my target application. So let's have a look at what are these controllers and custom resources that we get. So what do we have till now? So we have a GitLab project. We have our application source code there. We have a Kubernetes cluster, which has been bootstrapped with Flux. What did it result into? So we have one of the controllers, which is called a source controller, that is responsible for the reconciliation of a custom resource that is called the Git repository. Important. None of these configs is something that we have to manually build. It's kind of an outcome of the bootstrapping process. But we need to see how this is configured in order to understand how Flux is applying our changes to the cluster. So as you see here, of course, it's a custom resource which is having a particular namespace. And then under specs, you see the interval. That's the interesting part. So here we specify at which interval the source controller is going to check for the changes in your source code. And then through the reconciliation of the custom resource, which is the Git repository, those changes will be applied on your application that is deployed in the cluster. But who applies that? So Git repository or source controller is just checking for a change. But now we need another controller in place so that those changes are now applied to the cluster. So that's where customized controller comes into the place. And it is responsible for the reconciliation of a custom resource called customization. And similarly, you would see an interval at which it checks for the changes and thereby applies it. So Git repository checked for the changes and customization now applies it. So this is the interval at which your changes get applied. What I missed, however, so I go one step back because that's interesting as well. So I talked about the token auth method, right? And here you see we have a secret ref which is given. So that's the Kubernetes secret which gets created when we do the Flux bootstrapping process. So that's the secret used by the Flux or by the source controller in order to read from your GitLab project. Okay, so then we can proceed forward. Now we are good. So every time I change something on my application manifest, I can be sure that the source controller, customization controller takes care that those changes are then applied to my cluster. But is that all? Probably not. We still have a missing link here, and that's this part where we release a new version of my application now available on the container registry, but no one or someone has to keep looking for it and thereby apply it. So this is where the image automation controller now comes into effect. And it, of course, is also responsible for the reconciliation of few custom resources. So let's have a look. What are these custom resources? So we have the image repository, very similar to the Git repository custom resource managed by the source controller that we saw. And here, instead of specifying your Git project, your GitLab project or Git repo, you're specifying the image repository or the container registry. Of course, you have an interval as well, the interval at which the image controller is scanning for new versions of your application that is released. Then you have an image policy, and this is the rule book by which the image scanning takes place. So as you see, as a best practice, we use semantic versioning here. So I have put the policy in place so that for every minor as well as patch upgrades, there will be an automatic application of this new version of the application that is available. It would be applied. But probably as a best practice and depending on your use case scenario, you could just do it for patch upgrades and keep the minor as well as and definitely the major upgrade for a review and then only pass it through a human quality check. And then finally, you have the image update automation. Now that's the guy who will, after scanning for the latest version of your application, it will apply those changes to your target environment. So now if I try to build the whole picture, this is what happens. So we have a CI pipeline releasing a new version of my application as a new tag on Artifactory or any container registry you're using. And then this is taken into account by the image repository, which scans for a new tag according to the policy that you defined, numeric, alphabetical, or semantic. And then image update automation will now update the deployment manifests or your application manifests, which are on your source code side on the Git repository. And now, since your source controller and your customization controller are already set up so that every change in one line of code will do something to your application, these guys will come into effect and finally update your application. So that's more or less the big picture. But it's all theory till now. So let's try to make it a bit exciting and let's go for a demo, how this works in real practice. So what you see now is the source code. So this is a simple Flask application. We do it for more complex environments, but for today's demo, we will just use one simple Flask application where I will just change the message that you see here, and I will trigger the pipeline by pushing a commit. Of course, you know you can always disable the feature of not triggering the pipeline automatically with every commit on GitLab CI. Okay, so now the pipeline is triggered and it passes through all the stages which Marco mentioned with container scanning and tagging my commit. So you see now we have an incremental patch upgrade from 43 to 44. I will check on Artifactory, my container registry, if the new tag is available. Cool, that's available. So now I would go to my cluster and I would check on my deployment manifest if Flux did the magic. Yes, it did. So it updated to 44. So what happens in the background? So you see the image repository scanned and it found 38 tags. Then, according to the policy that you defined, we upgraded it from 43 to 44. That's all. Now, let's have a look at the state of my application. So you see the old pods are terminating, new ones are created, and of course, after some time, you will see these ones are gone. So next thing, probably as a best practice, we could also go one step further and say we want continuous testing in the whole pipeline or in the whole chain. So integrate some functional test as well as smoke test for your application. But here we do it manually. Just it's more about to check if my application did not blow up. And now you see the result. Honest acceptance, what I forgot here to show you is about the resiliency part. And that's something I realized last night. So I said probably it would be a good mix if I do it live here and not record it. So let's just try to do that here. So let's go to the cluster. And so let's see the deployments that are running. So as you see, my, okay, just ignore my app for the moment. So Flask app has 2 replicas. So what I'm going to do now is I'm going to edit something manually on the cluster itself and see if GitOps is able to override those changes or not. So let's just do Flask app. Okay, let's do it. And you see we have the number of replicas set to 2. I try to upgrade it to 3, and let's see what happens. So let's see the number of pods now. Oops, that's the wrong namespace. Let's do it. So you see now, since 10 seconds, there is a new one which has pinned up. But it's not late when Flux realizes that, oops, that's not what I have declared on my Git. And therefore, after a few seconds, you will see this is now gone. So that's the terminating part. Okay, so now I need to head back to the presentation. Let's go back to where we started. So let's try to recap. And we talked about efficiency, resiliency, and scalability. Were we efficient? Yes. We did hands-off deployment with 1 single line of code change. Were we resilient? Yes. GitOps kind of enabled us to ensure that it could prevent some accidental manual changes that someone could make. And by decoupling the deployment logic with the release cycle, we ensure that you can use the same Git repository and the customization to handle multiple expanding resources or the deployment of multiple applications when you expand or when you scale. So couple of learnings from our side. I think there is no golden rule book about what you should do and what not, but probably a few learnings. We find that securing your access credentials is very important. So not using personal access tokens from GitLab, that's not a best practice. So of course, using Kubernetes secrets with proper secret management like HashiCorp Vault, that's exactly what we practice. Having proper branch protection and pull request, especially when you talk about deployment on production, that's kind of necessary. You don't want to have accidental changes in prod, especially with things like the image automation controller. Then image scanning, I think what Marco showed with the vulnerability of your image and security exceptions, that's kind of also important. You don't want to end up with a super threatful image on your production. And clear definition of automation policies. If you're using one, that's important. If you're using semantic versioning, we try to be very clear. If you want to go for a patch upgrade, what's better suited for your use case, not doing a major upgrade with an automation policy in place. Then overusing automation controllers. Yes, in the demo, we overused all the controllers. Just for you to know, we did it for 1 minute, but that's not probably the most optimal case. So it depends on your use case again. And finally, GitOps, the magic wand for everything? No. It really depends how much value you get out of it and what your current state looks like. So, yeah. And with that, I don't know, are we done?
Not yet, Manisha.
Oh, okay.
Yes, thank you. So we have prepared for everybody a free workshop where you can set up a local K3s cluster and bootstrapping with Flux. So also you can observe the GitOps automation in action. Of course, you will need to have a GitLab account. And yeah, so saying that, it was really a pleasure to share this with you. Thank you so much. Meanwhile, you can scan the QR code to access the workshop, or just tell us. We will be happy to share this with you. So now we are ready for your questions.
And we don't have time.